Hi and welcome back. We have an interesting problem today. There are n students in a class numbered from 0 to -1, and the teacher is giving each student a problem. Whenever a student receives a problem, he will use some amount of chalk to solve the problem. After the teacher will reach the end, giving each student a problem, he will go back to the first student and restart the process again. And for example, let's see this example here. We have 22 chalks, the 22 units of chalk available in total, and we have 3 students. Each when, for example, the first student received some problem, so he will use 5 units of chalk to solve this problem, and the next student will use 1 unit of chalk to solve the problem, and until the chalk is not available and is not enough for the student to solve the problem, and then he will replace the chalk pieces, and we need to find the index of that student who will replace the chalk pieces. For example, we have 22 units of chalk here. The teacher gives the first student 1 problem. He used 5 units of chalk. We will be remaining with 17 units of chalk, and the next student will use 1 unit of chalk, and we will be remaining with 16 units of chalk. And then we're gonna have 5 here for the last student. He will use 5, and we will have 11 again. And you see, for the one complete run, we used 11 units of chalk, and then we will be left with 11 units of chalk. And the teacher goes back to the first student and repeats the process. At the end of the second run, we will be left with 0 chalk, and then he goes back to the first student again, and at which point this student will replace the chalk pieces because he needs 5 units of chalk, but there are 0 units of chalk. Okay, now let's go through an example. We have 3 students and 22 units of chalk. The first student will use 5 chalks, and the second one will use 1 chalk, and the last one will use 5 chalks. Now I'm gonna say 5 chalks because it's easy. And then at the end of this process, 11 chalks will be used, and we will be left with 11 chalks. And we go back to the first student, and we do the process again. In the end of the second process, the second run, we will use another 11, and we will left with 0. And when we go back to the first student, now this time he needs 5, but we have 0, so he will replace the chalk pieces. So the answer will be 0. So we can kind of simulate this process. We can go through and go back and wrap around to the first student, but this will take a lot because k could be up to 10 to the 9, and that could be a lot of work. So imagine we have like 3 students, each uses 1 chalk, so we're gonna go 1 1 1 and go back, and 1 1 1 and go back. This is going to be an O of k, which is pretty large, so we will get an TLE, which we don't want that. But in fact, we can see that in the first run, we don't care about the complete runs. The first run uses 11, the second run uses 11. Only the last run in which we will run out of chalks. For example, how do we know that? In the first run, we have 11 chalks. 11 chalks are used, and we can say that if in a complete run 11 chalks is used, then we will end up with the remainder. If we take the remainder, we will end up with 0 in the last run. So then what we can do, this 0 means, okay, we will start at some point the teacher will start at the first index here, and with 0 chalks, and then we can easily simulate this process because we know that this remainder to the end we will use 11, but when we take the module and we take 22 11, we get some remainder which is less than 11. So at some point we will run out, and this is going to be actually an O of n solution. So what we need to do, we find the remainder of k and go through one by one each student, at which point, at some point, we will reach a student for which we don't have enough, for whom we don't have enough chalk. So we can, for example, if we have 0, when we go back here, in fact, the first one will need 5 chalks, but we have 0. So the answer will be 0 here, the index of this student. Now let's see the next example in the problem description. We have 25 this time, and we'll have 4 students. The first one will use 3, and the second one will use 4, and the other one will use 1, the other one will use 2. That adds up to 10. So that adds up to 10. So in one round, we use 10 of them. So we can take the remainder again. So we can take the remainder, we will have 5. So in the last round, so we could, because we used 10 in the first one and we used 10 in the second one, and we go back with 5. So when we go back with 5, so now we have the k, or rather r, so the remainder, we have 5, right? So we start here. So we have 5, he will use 3, we will be left with 2, and we go up to here. So now we have 2, but he needs 4. So the answer for this problem will be 1. So the only thing we need to do, we need to find the sum of these chalks that each student needs, and take the remainder with k. So here we're gonna say k modulo sum, and this will give us some remainder r, and we're gonna start from the first index and go up to another index I, as long as the sum, the current running sum, we're gonna add summing, like for example 3, and then we're gonna add 4 and 1, as long as this sum is less than the available k, which is the number of chalks. We can do this in linear time. Now if we have like, let's say 7, if we start at here, we have 3, and then we go up to here 7. Okay, so to this point we use 7. When we go to the next one, we know that this will be 8, but we started with 7. So we know that for this student we won't be able to provide it with the chalks. So this is the answer for 7. So we can do this in linear time, starting from the first one, or we can use the binary search to find that index. For example, let's look at, for the 7 case again, let's look at actually the 8 case. And we have the first, to this index, we use 3 chalks. To this index, the index 1, we use 7. To this index, we use actually 8. To this index, we're going to use 10. Now, as you can see, these sums are in increasing order. So we can use binary search on this problem. We need to find the first index, which is strictly greater than 8. So this is going to be 10. We can use the binary search for that. Or we can again start from the first one, and we can add, so we can start from the first one, okay, 3, okay, it's less than 8. So 7 is less than 8. 8 is less than or equal to 8, so that's okay. So 10, but at this point, that means if we reach this student, we need 10 chalks. We need to start with the 10 chalks initially, so that we can provide this student with chalks. So this won't be possible. So what we're going to do, we're going to find the sum and find the remainder. So basically finding the remainder is kind of simulate this process. Start from the beginning, go to the end, and go back, wrap around to the first student. And when we do some some complete runs, and then we have some reminder. So at some point we will be left with no chocks. So we find sum and take the modulo to find the reminder, and then we can use the linear search or the binary search, or in any case we will end up with n big O n solution. But I will use the binary search instead of the linear search. But the complexity is the same, but it's a little bit faster, in fact. Now let's see the code. I have already written the code. Here I find the number of students, and there I have the prefix sum array, and I find the prefix sums, and then I take the modulo to find the reminder, and then I use the upper bound, which runs basically binary search on the prefix sum array. This upper bound finds it uses binary search to find the first value that is larger than k, strictly larger than k, which is what we want. The k is here, the reminder again, and this actually returns iterator. This is of no interest for us. We can just subtract the beginning iterator, and also I subtract 1 because the prefix sum uses one more space, and this basically shifts elements, and then we return I actually submitted the code. You can see it's pretty good, and we have analyze complexity here. Let's just click. It says log n, but it actually is not log n. It's actually bounded about by big O of n, because we use here, we touch every element at least once, so we have it when we compute the prefix sum. Now although this part is log n, and this part is not the O of n, so we can take this as O of n, not log n. So basically this is the solution. I hope you enjoyed it, and stay tuned for other videos.